Okay, we're going to be completing the notes for Unit 5 and 7. Again, we're talking about how to find information given that things are similar. And like I said, I call this the proportionality chapter. So we're on day 4, and we've got the notes for Unit 7-3. And we're going to look at the workbook pages on 195 and 199. And we're going to fill in some notes. So hopefully you guys are going to see exactly what I'm talking about how we're going to be setting up solving for proportions amongst similar right triangles and amongst similar polygons that have parallel lines. So let's go ahead and get to the notes. I really think that this is the one set of notes that you definitely need to take your time with. Okay, there's a lot going on here, and based on the information, you might have to watch this a few times just to make sure you understand it. Okay, so this line right here in a right triangle is called the altitude. And if this line, the altitude, is drawn from the vertex of a right angle to its hypotenuse. So if we draw this line from here, then the two triangles formed are similar to the given triangle and to each other. So if there's 3 triangles in this picture, so triangle 1, triangle 2, and then the big triangle is triangle 3, 1 and 2 are similar, and 1 and 2 are also similar to the big one. So if that's the case, then we can use this information. This needs to be a right angle. We can use this information to find all of this data. And so we're going to put an X and a Y and a Z here, and an A and a B here. Okay? Now, if you notice, the first theory we use is called the T method. So I'm going to redraw this picture over here and show you where I got this from. If I draw a right triangle like this, and I draw a line connecting the right triangle, if I cover up these 2 lines, I have a T. Okay? And so that's why we call this the T method. So essentially it says the measure of an altitude from the angle to the hypotenuse is the geometric mean, so this means average, between the measures of the 2 segments of the hypotenuse. Okay, so all of that vocabulary there, altitude, hypotenuse, geometric mean, what does it really mean? So if we label our hypotenuse, we'll see, first let's label the altitude. Let's label that Z. And then we look at our hypotenuse here, and we see that it's one long hypotenuse, but it's one long hypotenuse that has 2 parts. So let's name the first part X and the first part Y. And I told you that this is the proportion chapter. So if I want to know the average of the 2 segments of the hypotenuse, I have to have the X on the top of one proportion and the Y on the bottom of the other. And so if I'm going to compare the mean, I have to compare them both to Z. Okay? And so essentially, I'm going to make a T when I find these numbers. I'm going X over Z, Z over Y. So when we do these 2 practice problems that we're about to do, and we'll do more than 2, I want you guys to really think about, you're going to draw a T when you write your proportion. So let's go ahead and look at this first practice problem. So I have a hypotenuse that has a length of 19. The segment on the left is the length of 12. The segment on the right is the length of 7. So the first thing I want to do is set up a proportion. 12 on one side, 7 on the other. I want to relate the 12 and the 7 to the length of the altitude. So I'm going to put x on both sides. Now, as we've talked about in this entire section, we're going to cross multiply to prove, what the answer is. So I'm going to go ahead and do that. And I get x squared is equal to 84. This is where we're going to need our calculator. You guys can factor tree if you like, but just a reminder, and again, this is one where you might want to pause the video and rewind and look at exactly what's going on here. Your calculator will do the math for us, okay, when we're trying to find the geometric means. And I've shown you guys this trick, but when you go to y equals, you can put in whatever number you got and divide it by x squared. Okay, and so the calculator is taking our number and dividing it by the function of x squared. And so when we go and we look at the table, the calculator breaks it down into factors. So 1 times the square root of 84 is what we currently have, because see, that's what we're doing. We're taking the square root of both of these numbers so that we can get x by itself. If we factor 4 out of 84, then square root of 4 is 2, and then square root of 21 stays square root of 21. It's a perfect factor. So we go down and we see no other perfect factors. So the correct reduced answer is 2 times the square root of 21. You could also just do the square root of 84 in your calculator to come up with the decimal form, and it's 9.17. We want to go 2 decimal places. So x is equal to 9.17. And that makes sense because we said it's the geometric mean between these two sides. Not add them up and divide by 2, but we're actually going to multiply them and take the square root. So x is equal to 9.17. So that makes sense. Let's practice this one more time. So let's do it a little bit differently. Okay. So we set up our proportion. We want to compare this and this. 6 and x. It's going to go here. It's going to be 8 on both sides. So now we, again, cross multiply and solve. We get 6x is equal to 64. Well, 64 divided by 6. X is equal to 10.6 repeated. All right, I'm going to give you one more problem, and I want you to, I'm actually going to give you 2 more. I want you to do these on your own, and then pause the video, and then I'll have the answers checked for you. So go ahead and pause the video, do those 2 on your own, and then we'll come back and talk about it. Okay, so we had 6 over x, and again I'm going to trace the t, and then x over 4. So x is equal to 2 times the square root of 6. If you did it for decimal version, x is equal to 4.9. For this one, we had 6 over 4 and 4 over x. So x is equal to 2.6 and repeated once you cross multiplied and solved. Another way to handle this, because right now the issue is we haven't been able to solve for this side. Well, if you look, if this is a t right here, then this is an L. But so is any 2 sides of this thing make an L. And so we're going to do what I call the L method, okay? And so we're going to talk about it, how we get it. We're going to get all the vocab out there, and then we're going to actually talk about the relationship. So if the altitude is drawn from the vertex to its hypotenuse, which it is, then the measure of a leg of the triangle is the geometric mean between the measures of the hypotenuse and the part of the hypotenuse that's adjacent to the leg. So let's talk about it, okay? So if we have a leg, X, and they have hypotenuse Y and Z, then we're going to make an L, okay? We're going to do X over Y plus Z, because see, you can tell we're doing the big triangle right now. And we talked about this in the last section. And then we're going to do just Y over X. Because again, we're talking about the big triangle, and now we want to do just a little triangle. If it was A over here, we would do A over Y plus Z, and then Z over A. So I'm going to put up a couple examples and give you guys a chance to look at these, and then we'll talk about them. Okay, so in order to solve for Y, and again, this was the whole thing here, we want to take the whole hypotenuse over the leg. So I'm going to go 16 over Y, and then I want to come back and do Y just over the part that's adjacent to what I'm doing, Y over 4. So when I do that, I get Y squared is equal to 64. So when I take the square root of Y, well, we know the square root of 64, that's perfect square. Y is equal to 8. For number 4, I want to take the whole hypotenuse, so 9 over X, and then I'm going to come back and X over 4. Again, we cross multiply, X squared is equal to 36. And then we solve. Square root of X, square root of 36, X is equal to 6. Alright, I gave you 2 easy ones for the review, but no matter what happens with numbers, it's still the same rule. Take the whole hypotenuse over the leg and set it equal to the leg over the hypotenuse, and then solve, okay? So go ahead and do 5 and 6, pause the video, and we're going to come back with the answers. Okay, so hopefully you took the time to set this up, and if you don't understand, I really want you to rewind the video and take a look at how I got this information. So I did 12 over Z, Z over 3. Cross multiplied, Z is equal to 6. 50 over Z, Z over 40. Cross multiplied, Z is equal to 20 times square root of 5, or 44.72. Okay? Now, for 7 and 8, I want you to take, you're going to do the L method and the T method to solve different ones. So you have X, Y, and Z. X and Z are going to require you to do the L method. Y is going to require you to do the T method. So go ahead and pause the video, take a look back at these in order to answer these questions. Okay, so here's the 3 answers for 7 and 8. For X, I did 18 over X, X over 8. I got 9.79, or 4 times the square root of 6. For Y, I did 8 over Y, Y over 10. I got 8.94, or 4 times the square root of 5. And for Z, I got 18 over Z and Z over 10. And that gave me 13.41, or 6 times the square root of 5. For number 8, for X, I did 11 over X, X over 7, 8.77. For Y, I did 7 over Y, Y over 4, Y is 5.29. And for Z, I did 11 over Z and Z over 4, 6.63, or 2 times the square root of 11. Because these are so involved, I want to go ahead and I'm going to stop this video, and I'm going to create a second video for part 2, the parallel lines. But I want to go ahead and talk about the workbook work. So I believe it was page 195, 11 through 35. 11 through 25 just gets you used to setting up the proportions. So for 11 through 19, you're just going to say 9 over X, X over 4. And then you're going to solve it by cross multiplying and solving. It's just getting you the idea of how do I set this up. And then for 20 through 25, you're going to look at relationships. Q over R Well, that's leg over leg. So then in this triangle, it's going to be t over y. And so that's why I know t goes there. Okay, so I just want to look at what are the relationships there. And then for 26 through 35, you're actually going to be solving based on what method you need. Remember, if it's out here on the side, it's the L method. If it's in here in the T, you're using the T method. So again, 26 through 31, 32 through 35, it's just setting up the same idea. You're going to use either the T method or the L method to solve them. Go ahead and do these problems, and then we're going to stop the video here because I think we've reached long enough. And when we check off all of these, then you'll be ready to move on to parallel lines and proportional parts.